I'm really hoping I'm recording the right thing online. So I'm going to make what looks like Post-it notes. So I've got 2, 3, 4, 5, 6 orange that are supposedly all the same size, but I'm not going to waste time to make them all the exact same size. Then I've got one that's yellow, and then I've got 3 that are pink. So let's pretend these are in some type of container. This is a sample. I'm using a very small sample on purpose here. So this is like some raffle, and those are my options. Those are all the exact same size. I'm reaching into a box where I can't see anything, so I don't know any different. And those are different money values. So let's say that the yellow one is $10. The pink ones are $5, and the orange ones are $1 each. So like I get to play the game, I get one of the different ones. So there's a whole bunch more of them. I'm just using a small sample to show you an example of it. Let's say the company says you win an average of $4 per time you play. So that's their what? What do I write right there? What? They're claiming that that's their null hypothesis. Let's say people are skeptical and they don't think you're really getting that. We would probably be testing what instead? Everybody's with me there. And so I take a random sample of 4. And let's say that I am a terribly unlucky person and I just so happen to get those 4. My sample size I'm going to switch it. I'm going to make it 2 and I'll explain why in a second. I get this sample size. Well, my X bar is what? All of those are $1. So my X bar is going to be what? So let's say math occurs. So just pretend that because of this, we would decide to do what? So our data said what? Writing it like this. What did our data say? I did the sample, I got 4 orange. Our data showed that it, what versus $2? If I actually added all these up, I've got 10, there's 15, so 25, 26, 27, 28, 29, 30, 31. 31 divided by 10 is what? 3.1. So our data showed that it was less than $2, but it actually wasn't. So this was a what? Type? Which one? Our data showed the direction of the alternative. That's type 1. So in this scenario, if this were actually a game and the company said, these people are trying to tell me that they aren't winning at least $2, and you're talking to like the CEO, he's not the one who's putting the stuff in the boxes anyway. So he says, I really need you to go check and make sure. We ran the data and we said, bad news, it looks like you really are giving out less than $2. So what happens? So that's our scenario. What are our consequences now? They have to fix it. So this CEO now says, well, then we need to account for that. We need to start adding in more money. But did they even need to? No. So would I ever know if the mean really was 3.1 if I had all those that were in there? No. So I took a sample and I based my conclusion off of a sample and we adjusted everything because of that sample. I'll never ever know that I was wrong. So in this same scenario, what happens if I'm going to change the claim because we know that the mean is 3.1. Let's say that the boss says, they're claiming, he says, oh, I'm telling people we're giving away at least $4 on average. We're giving away over $4 on average. And I go take a sample, and my sample just so happens to be I can drag it. These three, the $3 $5 and the $10. So that's 10, 15, 25, 25 divided by 4. It gives me what? 6 1/4. I think. So in this case, I'm going to type one error again then. Maybe I don't want to talk about both of them. What questions do you have on the first scenario that I said? Like, do you get what actually happens behind the scenes? I think that's what you guys aren't getting is like what actually happens. Because the way you're writing some of your errors is like I take a sample. What that sample does makes my decision, but my sample might have been a bad sample. I don't know. Just unlucky. Are there questions on that? Was that even helpful at all, or is that where you were before?
Does that like being like unlucky, does that affect any of the consequences?
Okay, so I'm purposely showing you behind the scenes of where it went wrong. If you do a random sample, you're accounting for that the best you can. It just so happened that that's why we call it an error. Like you did everything right. It was just that weird circumstance. So like you'll never know that you made the error. You'll never know that it was a weird scenario. So that doesn't account into any of the consequences though.
So if the sample is actually true, would that be type 1?
If
the data said it wasn't true.
Okay, no. So a type 1 is our data shows the direction of the alternative when that wasn't really the case.
So it proves the alternative hypothesis true,
But it shouldn't have been.
But you also, aren't you not allowed to say that the null hypothesis is true?
Right.
Okay, so you just have to word it. a little bit.
Yeah. You never accept the null hypothesis. So like the background thing here, like, okay, that was a good way to ask that. I told you that we went through the math and did this, right? This is something that will never, ever, ever, ever be known to anyone. I was just showing you that because we wanted to talk about context. So I'll never know the answer to null hypothesis is true or null hypothesis is not true. Questions, more questions?